Have you ever wondered what lies at the edge of our understanding? What cosmic wonders remain hidden from our view? Today, we embark on a journey to explore one of the most fascinating and mysterious objects in the universe: black holes. These enigmatic entities have captivated scientists and stargazers alike, sparking our curiosity and challenging our perception of reality. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Imagine a place where the very fabric of space and time is warped beyond recognition, a place where the laws of physics as we know them break down. Our journey will take us to the very edge of these cosmic abysses, where we will delve into their formation, their bizarre properties, and their profound influence on the cosmos. Prepare to be amazed, to be challenged, and to have your mind blown wide open. Let's begin our exploration. Imagine a star, much more massive than our sun, reaching the end of its life. It has exhausted its nuclear fuel and can no longer support itself against its own gravity. The core collapses in on itself, creating an incredibly dense object. This object is so dense that its gravity warps the fabric of space-time, creating a region from which nothing can escape. This, my friends, is a black hole. Think of it like a cosmic vacuum cleaner, relentlessly sucking in anything that ventures too close. But unlike a vacuum cleaner, a black hole doesn't store the material it consumes. Instead, it traps it forever within its infinitely dense core, known as a singularity. Black holes are not empty spaces, as the name might suggest. They are regions of extreme density, where matter is compressed into an infinitesimally small point. This density is so extreme that it boggles the mind. Join me as we continue to explore the strange and wonderful world of black holes. Imagine approaching a black hole. As you get closer, you'd notice something strange. The pull of gravity would increase dramatically. This is because the gravitational pull of a black hole is not constant like it is around Earth. It gets stronger the closer you get to the center. Eventually, you would reach a point where the gravitational pull is so strong that not even light can escape. This point of no return is called the event horizon. Think of it as a boundary in space-time. Once you cross it, there's no coming back. The event horizon is not a physical barrier. You wouldn't feel anything special as you crossed it, but from that point on, you would be trapped forever within the black hole's gravitational grip. The size of the event horizon depends on the mass of the black hole. A black hole with the mass of our sun would have an event horizon with a radius of only a few kilometers, but supermassive black holes, which can have billions of times the mass of our sun, can have event horizons that are larger than our solar system. In the next section, we'll delve into some of the mind-bending facts about these cosmic monsters. Black holes are truly bizarre objects, and the more we learn about them, the stranger they seem. Here are a few mind-blowing facts that illustrate just how fascinating these cosmic entities truly are. Black holes come in different sizes. We have stellar mass black holes formed from collapsed stars, and supermassive black holes, millions or even billions of times the mass of our sun, lurking at the centers of galaxies. Black holes are invisible. Since not even light can escape them, we can't directly observe black holes. We detect them by their effects on their surroundings. Black holes are messy eaters. As matter falls into a black hole, it forms a swirling disk of superheated gas called an accretion disk. This disk can emit incredibly bright X-rays, which we can detect from Earth. Black holes can merge. When two black holes collide, they create ripples in space-time called gravitational waves. These waves were first detected in 2015, confirming a major prediction of Einstein's theory of general relativity. These are just a few of the many fascinating facts about black holes. As we continue to explore these enigmatic objects, we are sure to uncover even more surprises. Black holes are not just cosmic vacuum cleaners, they are also cosmic laboratories where the laws of physics are pushed to their limits. One of the most mind-bending consequences of a black hole's intense gravity is its effect on time. Einstein's theory of general relativity tells us that gravity warps time. The stronger the gravity, the slower time runs. Near a black hole where gravity is incredibly strong, time slows down dramatically relative to an observer farther away. Imagine you could travel close to a black hole and then return to Earth. You would find that you had aged much less than your friends and family who remained on Earth. This is because time would have passed more slowly for you near the black hole. Another bizarre effect of a black hole's gravity is something called spaghettification. If you were to fall into a black hole feet first, the gravitational pull on your feet would be much stronger than the pull on your head. This difference in gravity would stretch your body out like a strand of spaghetti. These are just two examples of the extreme physics at play near a black hole. As we continue to study these objects, we are sure to uncover even more bizarre and mind-bending phenomena. Section 6. Galactic Architects, Black Holes, and the Cosmic Web. Black holes are not just fascinating objects in their own right, they also play a crucial role in the evolution of galaxies. In fact, astronomers now believe that supermassive black holes reside at the centers of most, if not all, large galaxies, including our own Milky Way. These supermassive black holes are thought to have played a key role in the formation and evolution of their host galaxies. As gas and dust fall into a supermassive black hole, it releases a tremendous amount of energy, which can heat up the surrounding gas and prevent it from collapsing to form new stars. This process is thought to regulate star formation in galaxies, preventing them from growing too large too quickly. In a sense, supermassive black holes act as galactic architects, shaping the growth and evolution of the galaxies they inhabit. Furthermore, the jets of energy emitted by supermassive black holes can influence the intergalactic medium, the vast spaces between galaxies. These jets can heat up and ionize the intergalactic medium, influencing the formation of future generations of stars and galaxies. Section 7. Imagine the unimaginable analogies for the mind. Black holes are notoriously difficult to wrap our heads around. Their extreme properties and bizarre effects on space-time can seem like something out of science fiction. But analogies can help us to visualize and understand these enigmatic objects. Think of a bowling ball placed on a trampoline. The bowling ball represents a black hole, and the trampoline represents space-time. The bowling ball's weight causes the trampoline to sag, just like a black hole's gravity warps space-time. Now imagine rolling a marble across the trampoline. If the marble doesn't get too close to the bowling ball, it will roll past it in a straight line. But if the marble gets too close, it will be caught in the bowling ball's gravity well and spiral inward. This is similar to how a black hole's gravity affects objects that get too close. If an object crosses the event horizon, it will be trapped forever, just like the marble that spirals into the bowling ball. Another analogy for a black hole is a cosmic drain. Imagine a bathtub full of water. If you pull the plug, the water will spiral down the drain. The drain represents a black hole and the water represents matter falling into it. These analogies are just a few ways to visualize and understand the mind-bending nature of black holes. While we may never be able to fully comprehend these cosmic wonders, analogies can help us to appreciate their strangeness and their importance in the grand scheme of the universe. Section 8. Unlocking the Cosmos. Black holes as keys to the universe. Black holes are more than just cosmic curiosities. They are powerful tools that can help us unlock some of the biggest mysteries of the universe. By studying black holes, we can learn about gravity, the nature of space-time, and the evolution of the universe itself. For example, black holes played a crucial role in the early universe, seeding the formation of galaxies and shaping the cosmic web we observe today. By studying these ancient objects, we can gain insights into the conditions of the early universe and the processes that led to the formation of the structures we see around us. Black holes also provide a unique laboratory for testing Einstein's theory of general relativity. This theory has been incredibly successful in explaining the behavior of gravity in the weak gravitational fields we experience on Earth and in the solar system. But black holes represent a regime of extreme gravity where general relativity can be put to the ultimate test. So far, general relativity has passed every test we've thrown at it, including the recent detection of gravitational waves from merging black holes. But as we continue to study these enigmatic objects, we may yet uncover new physics that challenges our understanding of gravity and the universe itself. Section 9. A final thought. The universe beckons. Black holes are a testament to the power and mystery of the universe we inhabit. They are places where the laws of physics are pushed to their limits, where time and space are warped beyond recognition, and where the very nature of reality is called into question. As we continue to explore these enigmatic objects, we are sure to uncover even more surprises and mysteries. Black holes are a reminder that there is still so much we don't know about the universe. but they are also a source of inspiration, driving us to ask bigger questions and to push the boundaries of human knowledge. So the next time you look up at the night sky, remember the black holes lurking out there in the darkness. They are a reminder that the universe is a vast and wondrous place, full of secrets waiting to be unlocked. The journey of discovery is just beginning.